Greetings, the Astro 30 here yet again with a brand new video for you. Now, today on the lab we've got a project that I'm going to build anyway, called a dim bulb tester, or a DBT. Now, what is a dim bulb tester, I hear you ask? Well, for those that don't know, a dim bulb tester is a current limiter that you put in between your line, your power, your mains power, and whatever device like an amplifier or television, whatever it is that you're testing, a device on test. What this will do is, in the event that the device on test has a fault, like a direct short circuit across its line cord for instance, then you're not going to have the nuisance blowing of fuses and circuit breakers in your breaker box. That's the whole entire point. So for this project I've got a HB6012 enclosure jiffy box from JCar, which is 197 by 113 by 63, which should be big enough. I've also got an Osram 46 watt halogen bulb. Now, normally a dim bulb tester has a incandescent bulb, but they're getting extremely hard to get hold of considering they were banned back in 2015. And a halogen, as I did some research, will work just fine as a replacement for the incandescent bulb. You cannot use LED bulbs. I'm not sure about dimmable, but they will not present the same voltage drop across the circuit as what is needed. So I wouldn't try using LED bulbs. Anyway, I've got a single main socket with a switch and an Edison screw 27 light fitting. I've also got a old figure 8 power cable that I'm going to use to actually supply the mains in cord for. Now, all of this sitting on the desk came to around about 40 bucks. These globes are $5.25, I believe they are, from Bunnings. And why is a dim bulb tester important? Well, if you don't have one, this is what can happen. Hopefully nothing happens. Oh. Don't try that at home. I accidentally did that and I kept the footage for demonstration purposes. The active and neutral connections of the line cord were actually shorted together due to my own stupidity, and that's what can happen. I took out a circuit breaker and I had to go downstairs to reset it, which is annoying. However, how long has the dim bulb tester been around for? I'm not sure. It does date back to the late 50s, maybe even earlier than that. But ever since the advent of valve state equipment, especially valve state radios and stuff, aligning them and testing them was always done on a dim bulb, so that's how it came about. I don't know who invented it, but it's really, really cool invention. I will now show you a schematic of how this is to be wired. However, I'm going to preface this video with, this is in direct contact with the mains all the time, regardless of how it's configured. So if you're following along at home, you're doing so at your own risk. I will not be held liable for accidental electrocution, and this is definitely not a project for kids, just saying. So if you do not know what you're doing, either get someone that's competent with working around mains voltages to do it for you, or don't attempt it. Anyway, let's have a look at that schematic. And there it is there, as crudely drawn as it is, and I apologise for that in advance. However, the way this works is we have a light globe which is in series with the live wire. So it goes out on through this switch, which is our load switch, going to the DUT, device under test. The neutral is just connected directly back to the line. So how this works is, this light globe works like a ballast. In other words, the more current that flows through it, the higher the voltage drop is going to be presented across this line. So in essence, the brighter this globe glows, the lower the voltage is going to be experienced at the DUT. Meaning that if these two wires, which is kind of counterintuitive, but if the live and the neutral at this end were shorted together, basically this is now turned into a desk lamp. In other words, if this was shorted, this light will light at full brightness and it'll only draw the current through the globe that it requires to light it up to its full wattage off of the 240 volt line. or 110 line, depending on what country you're in. Now, some may argue that this switch should be before the light globe to prevent any arcing that may happen across this switch as soon as the load is applied to the globe. That's a reasonable argument, but for all intents and purposes, it doesn't really matter where this switch is. You could not have one altogether, and this light globe will still experience the same loads that it would if this was shorted anyway, regardless if this switch was here or not. So it makes no difference. As I said, basically this light globe is acting as a ballast. Now, there are other substitutions you can use here for a ballast. You can actually use an electric heater as a ballast in series with whatever device you're testing, especially a fan heater, because they have an element in it with a certain resistance, and if you have it on, say, the low setting, and if the heater stays on, well, then you know that then there's a short circuit there. I have not tried that. There have been people on YouTube that have. I wouldn't recommend doing it. So that's our schematic. Now, I chose an ABS plastic box because, one, it's easy to work with, especially when you've got to cut out large holes and stuff that you don't have like the required bits for it, because the base of this is going to need a fairly large cutout in order to accommodate the bits sticking out for the wiring. And also, it provides some isolation from the circuitry that's going on here, so that you can handle this box quite safely on the desk and move it around without having to worry about coming into contact accidentally with mains potential voltage. So anyway, I don't have a hole saw big enough to do that. So what I'm going to do is I'm going to probably drill a series of perforation holes, like 4mm or so, around a square, and then just punch it out to accommodate the socket. So let's get started building this and testing it. What is Jen doing with the internet? Anyway, I've laid things out. I've got some M3 screws and some washers to put through here because, well, I couldn't find long enough M4s. However, I did end up with a problem that this screw and washer will not fit through this hole. It will sit on top of there, and the screw is long enough to attach it to the case. I was a bit worried that the fascia panel that comes off was going to interfere with the screws, but no, it doesn't. It just fits on there nicely. So the fascia panel is not really necessary. But this is how I'm going to lay it out. I'm going to have the light globe up there. The cable's going to come in at the top here, and the switch is going to be down the bottom. Also, I forgot to mention that the earth is not used. In other words, this whole thing is not earthed. It's isolated from the earth. There's a reason for that too, which some people may disagree with. I want to keep the device under test completely isolated from the mains as much as possible with this sort of device, so we're not also tripping RCD protectors and stuff as well. The thing is, you would normally measure across your active and your earth pin of the device under test first before plugging it in anyway, just to make sure that there's no earth leakage there or a direct short. But for what I'm doing, this should be fine. Sweet. Well, I got my perforated hole that I wanted to drill for the power socket. What a mess. Now, with a bit of gentle persuasion, I should be able to pop that out. Right, that was hard work, but the hole's cut out now. And, albeit one of my holes for the actual mounting of the sockets off, it's not far off. So all I have to do is just clean this mess up a bit with a file, make it a little bit neater, and then I can drill my hole on the other end for the cable to come in, and we move on. Penis. Right, well, I've got my power cord stripped back, left a good 25mm length of wire on there. I've shortened the cable to roughly a little less than a metre. Doesn't need to be any longer than that. And I've got a rubber grommet through a hole, and I'm going to use some cable ties around the cable here to act as a strain relief. This next bit's going to be a little bit awkward because I need to get the neutral wire into this socket, which it might work. I'm going to tin this wire and the active wire as well, just to make sure that it has a nice solid connection. A lot of electricians out there may disagree with this, but I just want to make sure it's got a solid connection, that's all. Okay, so this needs to be wired correctly, so that needs to go through the hole into the socket, and using a screwdriver clamped off like that. I mean, I can verify it with a multimeter that I've got good contact. I'm just screwing the earth terminal in so it's not floating around. Now, as for the active, that needs to go through the light globe. So I need to cut this wire probably about where my finger is, and this will come from the socket back to the light globe. I think it's going to be long enough, although it may not be. Never fear, the Astro 30 is here. There we go. I think that wire will be long enough, so I'll strip him back and do what I did with the neutral wire. I just tin the end of it and stick it in the socket. So now I'll just guess how much length I'm going to need of this wire. About that much should be long enough, so I'll cut him back. I'll strip him back. Now, the reason I'm doing this in this order is because this socket has to pass that way through its housing. Of course, lining up the notches correctly, like that. So trying to actually get the wiring in there with this, you know, in its place is a pain. There's just one thing with these sockets. You actually have two live wire connections. Now they do this so that when you, neutral's over here, earth's there, one's marked live here, but what they do is they run the live wire into the light socket, and by joining another piece of wire to that same point, they run that back down to your light switch, and the wire running back up from the light switch goes into, well, I'm assuming the live on this side. So I need to make sure that this connection here, because one of them is a dummy connection, it's not connected to anything, and I believe it's this one. So I need to make sure that this is actually connected to our center pin down there. So I'll grab my multimeter. So this is only relevant for Australian light fittings. American light fittings are probably completely different. So I'll connect one end of my lead there and just touch the center. Okay, so the one marked live, which is there, that's our dummy, that doesn't connect to anything. The one above it, next, directly opposite, well, to the right of the earth, that's actually connected directly to the center point of the housing, which is where the center point of the globe is, which is that connection there. And this one directly under the earth connection on the left is the neutral. So the one directly next to the live marked one is neutral. The one above it is the actual one that goes to the light globe. So it's these two connections here we have to use. This one here and that one here. So I'll make it come in the live connection from the power point, or from the wall socket. If I can get my wire to go in there. And I'll make it come out of the neutral. Right, so I just want to make sure that I've got continuity between here and one of the pins, and of course from the neutral to the other side as well. So the active comes in there, which should be I've actually got that wired round the wrong way. That should be on that pin. So that pin doesn't go anywhere. So, alright, let me rewire this round. Never mind, I had it wired the correct way. I was thinking about it in the wrong direction. Obviously the neutral part of this socket is going out to our active. That's how it should be wired. Indeed it is. And this comes off of the plug, directly off of the active pin of the plug, which is there. That should go to the center, which it does, which makes perfect sense. And the switch is off. Okay, so neutral should be connected directly to the plug. It is. So I know it's wired correctly, so now I can actually assemble this fully for the final time, and we can test it out. So I want to know what the resistance of this halogen light bulb is, and that'll become relevant later, but I need to know right now. So I'll put that across there. So we've got 84.1 ohms, roughly thereabouts. So we now know the resistance of the light globe. That's going to become important later. Right. For now, however, I'm going to start screwing this together. And there we go, all neatly screwed together there. I didn't want to over tighten these screws too much because it is actually deforming the washers and pulling it inwards. Same with on the light fitting. So I can screw my globe in. Okay. And I can put this fascia plate back over the power socket, which doesn't actually fit properly because of the screw. Didn't think it would. I mean, is it needed? No, not really. Yeah, let's leave it sitting on there. I might be able to hack a little bit out of here on the sides just to accept the screw a bit better. In fact, I might actually do that. Okay, I hacked a bit out. Don't know if that's going to make any difference. Well, that side it did. This side, not quite so much. I might need to go a little bit further on that. There, fits a bit better now. And it looks a bit neater. And that's the inside. As we can see, it's all neatly cable tied in. So all I need to do now is put the bottom cover on, because it doesn't need to be open now. And put the provided screws for the box in it. And then we can get about testing to see if all this work was worth it. Behold, the internet. Ah! No, I'm not serious. Now, you may be wondering why it was important for us to know what the actual DC resistance of that light globe was. Wrong one. Because we want to test this in the worst case scenario where we have a line cord, which I've got in my hand here, where both the active and the neutral are shorted together. Now that's counterintuitive, but if we measure the resistance across what comes in from the wall, if the lead will stay on there, we plug this into our tester and we turn the switch on. Currently, all happens. Alright. Well, that's interesting. There is no continuity. Okay, for some reason I am not seeing any continuity from my active on this power point to the active wire back out on the other side. I should be seeing the resistance of the globe from the inputs active, which you can't see, from the inputs active to the outputs active, unless I've wired something around the wrong way. No, I don't believe I did. So I've got no active connection to the socket. So I'm going to have to fault find this and see what I did wrong. Well, I can't fault it. The active connection of the globe is going, well sorry, the neutral connection of the globe is going to the active pin of the socket, and the neutral is connected to the neutral, but I'm not seeing the resistance of the globe through this shorted wire for whatever reason. However, the wire is still shorted, and I would honestly recommend that you don't try this at home, but it is just turning it into a light globe, and it doesn't work. Why doesn't it work? No, it's wired correctly. The issue is this socket. It's not allowing, because when I measure across here I cannot get any resistance from the globe, so, and I've tried every configuration and it should be wired right, but there's no resistance to the globe through the socket. So even though I'm getting continuity from each of these two pins to the pins on the other side, it's just not connecting to the globe. I mean, I even went as far as cutting off this top of this crap because I thought that maybe the globe wasn't screwing down far enough, but it's still not screwing down. It's not making contact with these contacts in here, so I don't know. Cheap piece of shit. Finally fixed it. It's this blasted socket. I trimmed off a little bit more of that excess plastic that was sitting over the top, and now I've actually got a good connection with the globe. Having said that, what I was meaning in the first place with if this line cord was shorted, we basically now turned this into a light globe. So if this was to be plugged into the line and we turn the switch on, see, it just lights up like a normal light globe. That's the whole entire point of this thing. Right, so now that I've solved the problem, and don't try that at home if you don't know what you're doing, by the way, I'm going to reassemble this all back into the case, double check that it works, and then we'll test it on something else like a transformer so we can see what exactly this does. This has got to be the most useless brand of E27 light socket I've ever come across. Imagine installing one of those in your house somewhere or in your workshop and you put a globe in and it doesn't work. I should have bought a HPM one but instead of the data, but whatever. Okay, it's all back together. I've verified I've got continuity through my globe. I've got my 160 VA toroidal transformer hooked up to the tester, and we'll see, we should see this light up a little bit and then dim out. The secondary is unloaded on this transformer. Didn't even see anything. I can actually hear it humming. Indeed. But there was very little inrush current with that transformer not loaded on the secondary. However, if I load it up on the secondary, we might see something a little bit different. Okay, I've got it hooked up to its power supply, which should present a little bit of inrush, but see, 160 VA transformers don't present much inrush to the line, so I'll turn it on. There we go. That's how it's supposed to operate. It lights up bright for a second and then dims out. And I could hear that the relay engaged on the power supply, so I know it's working. And there's very little inrush there. So we know that this little gadget does what it's supposed to do, which is protect the equipment and you from the line. Well, not so much you, but protecting your equipment and protecting your circuit breakers, RCD, whatever, from popping accidentally due to a shorted transformer. So this will prove invaluable for testing amplifiers from now on, and other such devices safely, so I know that I'm not going to accidentally blow a circuit breaker up or whatever. I don't have any rubber feet for this yet to stop it sliding around the desk. I'll get some later. That's really irrelevant. All I wanted to do was build it, get it to work, and demonstrate how it does work. And I managed to achieve that after screwing around with that light socket for about half an hour to an hour. So I'm going to leave this video here. If you enjoyed it, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and become a Patreon supporter for as little as $1 a month. You don't have to pay $1 a month to follow me on Facebook. I know the English language is a bit of a bastard. Anyway, this is the Astro 30 saying, see ya, have a great day.